The first lesson in college algebra covers complex numbers. It's lesson 1-3 if you have a textbook. If not, these notes will suffice. All right, we start off with the definition of an imaginary number. So if x squared equals -1, I would take the square root of both sides to get x equals the square root of -1, which has been defined as I. So what we're interested in is powers of I. So if we do I to the first, that's going to be I. I squared takes you back to -1. And then I to the third, I to the fourth, I to the fifth, I to the sixth, and so on. So you need to memorize that I squared is -1. That is one of the most important facts from this lesson. All right, I to the third. If I break up my power of 3, I would have I to the first times I to the second. I know that I to the second is -1, so I to the third is defined as -I. I to the fourth can be written as I squared times I squared. So that's -1 times -1. And that is 1. I to the fifth. I can write it as I to the fourth times I to the third times I squared times I squared times I to the first. So you have a lot of ways to get an exponent of 5. I'm just going to go this route. So -1, -1, and I would make a positive 1i. All right, I'm going to stop for just a second, and we have this summary here. All right, these are the first 4 powers of I. If you know them, this lesson again will be pretty easy. So I notice that I to the fifth is I to the sixth, I squared, because you add your exponents, you would get 6. -1, -1, -1, and I'm back to -1. So I notice that this is I, and then this next one is -1, and so I'm starting to see the pattern repeat. So if I did I to the seventh, I should get -I back, because I'm following along right here. So I to the seventh, I could do I to the sixth and I if I wanted to, or I could do I squared, and I. Just get a combination that adds to 7. I to the sixth is -1, and then I multiply by another I, and I get -I. So just remember that it repeats every 4 terms. All right, that is helpful when we go to solve questions like A. If I want to find I to the 23rd, I don't want to run this out all the way to 23 places. What I want to do instead is take my exponent, and I'm going to just take my exponent and divide by 4, because I know powers of I repeat every 4 terms. I'm going to do long division. So let's see, 4 times 6 is 24, so I'm going to do a 5. 4 times 5 is 20, remainder of 3. So what this is going to become then, I to the 23rd becomes I to the third. So my remainder becomes my new exponent. And then I to the third, from right there, is -I. Oops. Okay. For part B, the question is 1 over I to the -11th. I want to simplify that. Okay, if I have a negative exponent, I can make it positive by writing the reciprocal. So I'm just going to flip this over, which is just I to the 11th. If I take 11 divided by 4, I'll get a remainder of 3 again. Now, you won't always get a remainder of 3. It just happens that way with these examples that I have. For C, I have I to the -7th. I can write the reciprocal of that. to make my exponent positive. I to the 7th, let's see, there's 1, 4, and 7 with a remainder of 3. I know I cubed is negative I, but I can't leave I in the denominator. That is like having a square root in the denominator. So I'm going to rationalize it by multiplying by another I, because now I have created this situation where I have negative I squared on the bottom, I on the top, but I know that negative I squared is negative 1. I squared is negative 1. So I have I over 1, and that just comes down to be I. So that's all the work I would have for C. All right, when you get into D and E, these are a little different. You have the square root of a negative number. So for D, it's the square root of negative 81. The first thing you want to do is you want to make what's underneath the square root a positive. And so you need to remember that this was negative 1 times 81, and the square root of negative 1 is I. So I automatically go from here to here. Taking an I out makes the 81 positive, and then the square root of 81 is 9. On E, it's the square root of negative 98. And that is going to be an I out front and then a 98 underneath. Now, some calculators are going to go ahead and simplify that for you. In college algebra, you can always use a scientific calculator. All quizzes, tests, everything is taken with a scientific calculator. So if your calculator breaks down the square root of 98 for you, by all means use that function. If it doesn't, you're going to have to break it down. So we're going to do a factor tree. 98 is even, so I can divide it by 2. Factors of 49 are 7 and 7. So the square root of 49 is 2 times 7 times 7. I have a pair of 7s, so they're going to come out, and that will make that 7 radical 2 times I. Just make sure your i's on the outside, or 7I radical 2. It doesn't make any difference to me which way you write your answer. You just need to choose one or the other. We're going to carry on here and do F and G. Okay, so F. That problem is the square root of negative 5 times the square root of negative 30. Now, there is a caution in your textbook on page 107. And what you need to watch is that the square root of A and the square root of B, if I multiply them together, that will equal the square root of AB, so long as they're both positive, or at least one of them is positive. So I'm just going to say so long as both A and B aren't both negative. One of them has to be positive for that to work. So it's wrong to say this is the square root of 150. I can't do that because both of these are negative. What you can do, though, is write that as I radical 5 times I radical 30. And then I have I squared radical 150. So now I can combine them. That's negative 1. And then the square root of 150, if I break it down, I can divide it by 10. Two times 3 times 5 times 5. There's a pair of 5s coming out. So I will have 5 radical 6. The 6 is from here. So negative 5 radical 6. Letter G is a division problem. So again, I'm going to make both positive by taking the I out front. And this one's nice because the i's divide out. Your book uses what we call compatible numbers, so I can write that as a quotient of or a square root of a fraction, and the square root of 42 divided by 3 will just be the square root of 14, because that's what 42 divided by 3 is. 14 doesn't break down. All right, here's your first set of practice problems. Before you do 4 and 5, I need to show you how to do A down here. So I accidentally put those two practice problems in a little bit early. So you can pause this video, do questions 1, 2, and 3, and then I'm going to show you how to do A down here in part B. Then you can go back and do 4 and 5. All right. So for part A, we want to leave all of our answers in standard form. So that means A plus BI is how you write your answer. So this number 2A is this problem right here. And basically it's just carrying on with what we did up here with our negative under the radical. So we're just going to clean that up first. I'm going to break down my 75 over here on the side. It's 3 times 25. And so that's 15 minus 5i radical 3 over 5. Again, that's 3 times 5 times 5. I've got a pair of 5s coming out. Okay, from here you can reduce. You can do 15 over 5 minus 5i radical 3 over 5. So you're reducing this way and you're reducing this way. It's important that you do both. So that is 3 minus I radical 3. And remember, you need to write your answer in A plus BI form. That just means the imaginary term has to be written last. All right, I'm going to end my video here. So from here, you can go back now and do practice problems 4 and 5. Our next video, we'll start with part B, number 2, part B, and then we'll carry on with the rest of your notes.